talk about absolute value today. Okay. Let's start with the graph. First of all, the absolute value symbol, ABS, is found under math number. Guys, you need to be off your phones and you need to be paying attention to this, okay? So the function family for this is absolute value. Right? The equation of the parent function, right? You know, the parent function is basically the most basic and simple form of this function. Y equals the absolute value of x, okay? Minus any transformation fancy stuff, right? Y equals the absolute value of x. That is the equation of the parent function. Now, do absolute value graphs have an asymptote?
I think so. No?
We didn't start talking about asymptotes until what? Rationals? No. No. None. That's what I should probably say, right? And then it's asking about the domain and the range. Well, you know what? Let's graph this. The absolute value of x, you can make a table, or you can put this into the calculator. If you decide to go with a table, just make sure that you plug in your values in for x and get the absolute value. So the standard would be 0, 1, 2, 3, -1, -2, -3. If you plug in a -3 in here for x, what is the absolute value of -3?
3.
3. -2.
2.
-1. 0.
1.
1, 2, 3. So
Thanks.
that's the way that you can do it. Or you can also go into your calculator and do math number abs x and close your parentheses. And you can graph it and you can see what the graph looks like. Or you can go to second graph and get your points as well, which is the same, right? -3, 3, -2, 2. Okay? So let's graph this. All right? What is your domain? Yeah, from the left to the right. Well, this graph covers everything. It keeps going on forever to the left because you have an arrow going to the left. And it keeps going to the right because you have an arrow going to the right. Domain is all real numbers. How about the range?
0.
Good. It starts at 0. Now this is looking at the y values, right? And we always start from the bottom. So 0 to infinity. Does it include 0?
No. No, yeah.
Yes, because that is a closed dot. Yep. So if it's including 0, we have to put a bracket, right? All right. Now, how about any zeros? What's another word for 0? Good. X-intercept. Do you see any x-intercepts here? 0, 0. Yep. It's right there at 0, 0. And the mine looks a little bit lopsided. There we go. Isaiah, write the step down. What is the vertex? 0, 0, right? You know, the parent functions are nice.
Don't anger
They're
the
so
numbers.
simple. Huh?
I'm talking to him.
What is the y-intercept? Is there one?
No.
Where does this graph cross through the y-axis? Right here, right? At 0, 0.
Oh, good lord.
Now, intervals of increase and decrease. So decreasing and increasing intervals. So remember, you know, when you guys look at these intervals, the easiest way to do it is to draw a line where your graph changes direction. So you have your graph here on the left, and then it changes direction at your vertex. Do you agree? So if you were to just kind of trace a dotted line right through where it changed direction, okay? What is the x number that this line goes through?
0, 0.
0, just the x number, right?
Okay.
And then look on the left. Remember, your intervals go with x values. So if you have an arrow going all the way to the left, you're going to negative infinity. And then to the right is going to infinity because you have an arrow, right? So now you can see that you actually wrote out your intervals here. You have negative infinity to 0, and you have 0 to infinity. Just tell me what the graph is doing. What is the graph doing from the left, from negative infinity to 0? What is this doing? Decreasing. And what is this doing from 0 to infinity? It's increasing. Please remember, increasing and decreasing intervals always use parentheses, never brackets. Okay? So increasing would be from 0 to infinity, and decreasing would be from negative infinity to 0. Any questions about that, Dylan? Now, let's talk about the end behaviors. End behaviors are basically just looking at the ends of the graph, right? Okay? I mean, I kind of think of them as kind of like the arms, okay? You can only do it if you have these arrows. What is that left end behavior doing? Where is it going?
Negative infinity.
Really? Is that left arm going down
Oh,
to negative infinity? It's going up to infinity, okay? 3 choices for end behaviors, guys. Is either going up to infinity, down to negative infinity, or it's going straight and getting stuck at an asymptote, okay? This guy is going up to infinity. Now look at your, oh no, oh my goodness, that one's the right one, isn't it? All right, so hold on. I should probably talk about this too. As x approaches infinity, if you're on the x-axis and you want to go towards infinity, which way do you have to go? If you're on the x and you want to go towards infinity,
Go
to the right. So this is actually talking about the right end behavior. As x approaches negative infinity, you're going to the left. So that one's the left. There we go. They almost got me. So what is the right end behavior doing? Where's that one going? It's also going up to infinity. Okay? Any questions about this? Is it coming back? You remember, it never left. Good. So let's graph this. Absolute value inequality. So whenever we have inequalities, okay, you can graph it the same way as if it were an equals, but you have 2 major things that you need to remember, all right? First of all, the line is going to be dotted or solid, depending on what your inequality is, right? If your inequality would look like an open circle, then what do you think your line's going to look like? Dotted. If your inequality was a closed circle, then your line should also be closed or solid, right? And your inequalities also have a less than or a greater than, right? So you also have to shade, because we're not talking about one solution. We're talking about like a whole area of solutions. It's either less than, so you shade below your vertex, or it's greater than, and you shade above your vertex. Does that make sense? Okay. So let's look at this one. Y is, what is this?
Less than.
Less than. Negative absolute value of x plus 2 minus 1. Okay. So you could easily put this into the calculator, into your y equals, and get some points. But how do you get the vertex from this? It's written in vertex form.
Isn't it negative 2 plus 1?
Yeah, negative 2, because it's opposite the number inside,
Negative 1.
right? Inside with your x. and then k, -1. So your vertex is actually at -2, -1. And then think about the transformations that happen to this, that happen to your parent function. If left 1 down, left 2 down 1, and then it reflects. So yeah, and there's no stretching or compressing, so really, here's where we are, right? And like I said, you can easily also put this into the calculator. All right? Good. I see everyone working. Looks good. SOLs are going to be here before you know it.
Don't you mean death?
What? No. Don't think of it that way. All right, so I drew my absolute value inequality like this, and then I go back and I look. I go, oh my goodness! What? It should be a dotted line. Man! So I know this happens to you too, right? If you do this, all you need to do, don't freak out, just go back and erase right in between. Okay? That's all you need to do. Just go back and erase a little bit in between the lines. Okay? And there you go, done, fixed. And I did that to show you because a lot of students do that, you get so in the habit. And you said this is less than, so where do we shade? Above our vertex or below? Below. So that means I'm going to shade down here below my vertex. Yes? And there we go. Done and done. Right? Not bad. Questions about this? All right. So tell me what happened here. Tell me the transformations. I think this is, after we do this, we can stop. You know your parent function is y equals the absolute value of x. So what kind of changes happen here? Tell me one.
Yeah.
Good. So stretch. Stretch. What else? Good. Left 99. Thank you. And down 10. Guys, what is my vertex for this? -99, -10. Great. And we'll stop. Stop. So let's look at the next problem. Y equals 1/3 times the absolute value of x plus 3 minus 1. First of all, what is the equation of the parent function here? Thank you. And then, what are the transformations? So, okay, so I heard one, compress. What?
Down 1. That's what
Down 1, yes. And what with the 3? Mm-hmm. Good. So, what is the domain? Think about what an absolute value function looks like. A sharp B, right? B for value, absolute value. So what is the domain? Good. -infinity to infinity. What is the range?
0 to infinity.
Is it 0?
Yeah.
But
you're going down from up.
if it,
Because I put it into the calculator.
yeah. So you said your absolute value function, I already compressed it, okay? It went left 3 and down 1.
Mm-hmm.
Well, then where does your graph start? What y number?
-3, -1.
-1.
So is it
All the way up to infinity.
Okay.
And remember, you can always graph this into your calculator so you can see. Now, let's talk about the increasing and decreasing intervals. So, You can draw a line that goes right through the vertex, right? What x number does that line go through? Positive 3? Negative 3, right? And then you have an arrow going to the left, so you're coming from negative infinity. You have an arrow going to the right, so you're going to positive infinity. It's the x values, right? Now, what is your graph doing from the left to the right, up to this, that line there? Decrease. And what is it doing from negative 3 to infinity?
Increases.
It's increasing. Okay? So you're increasing intervals from negative 3 to infinity. Remember, always parentheses. And it's decreasing from negative infinity to negative 3. Yes?
Mm-hmm.
All right. So, how about the zeros?
Well, there's 0 and 0.
There should be 2.
Yeah.
Yeah? Okay, you know what? Since my little drawing here is not very good, I'm going to put it in my calculator so that I can be absolutely certain. That's the 1, right? Now I'm going to look at my graph and see. Oh, yeah. Okay. My drawing was not to scale because what I did was I stretched it and I said compressed, didn't I? I didn't say anything, Ava. It was not to scale. Okay, so, all right. If I look for my zeros or my x-intercepts, it looks like, yes, there is one at 0, 0. And it looks like there's another one at 1, 2, 3, 4, 5, 6. Negative 6?
Mm-hmm.
Yeah. All right. So let's go to our table and let's see. When I go to my x equals 0, my y is 0. So this is a 0, right? So 0, 0, that one works. Let me go to negative 6 and see if that is a 0. Yes, it is, because the y value is a 0. So 0, negative 6, 0, and 0, 0. So good. Okay. There. Do this little disclaimer. Okay, I know, right? So let's look at the next one. All right.
What is that one? This is
Oh, is this the warm up? You know what? Then.
Now, yeah.
Okay, you know what? You guys try it. Try it on the little warm up half sheet. All right. Function family. Function family. Austin, what is it? Thank you. What is the equation of this parent function?
Never mind.
Dylan.
Y equals the absolute value of x.
Y equals the absolute value of x. So good. Now, do absolute value graphs have an asymptote, Jaden? Oh, okay, class. No.
No.
All right. What is the domain? What are we seeing here? What is this pattern? Absolute value graphs seem to have a domain of what? Okay. What did you guys get for the range here? Thank you. Negative infinity to 4 with a what? Thank you. Okay, so the vertex. Well, the zeros. Anyone find the zeros?
Yeah.
Yeah, what are they?
0, 0.
0, 0.
0, 0, and what?
0, 0.
And 4, 0. Okay, good. Now the vertex. Guys, I'm sorry. The vertex here, this 2 in front of the x, it kind of changes it a little bit, all right? I'm going to show you how to do it, the algebraic way that we've been doing, but I'll also show you how to do it in the calculator too, okay? So for the vertex, we always said opposite the number inside with the x, right? Opposite h, comma k. Well, the opposite of h there is 4, right? So it's 4. But you know how you have that 2 right there in front of the x? So if you have a number that's there in front of the x, you got to divide it by that. So then it really becomes 2. So weird, right?
Four.
I
So it's 2 and
know.
4?
2, 4. So here's the other thing that you should know. So this is negative absolute value of, what is it, 2x minus 4, and then what, plus, was it plus 4?
Yes.
Alright, so if I graph this, I see that it reflects, okay, that's what it looks like. Guys, is the vertex a maximum or a minimum? A maximum. So what you can do is you can go to second trace and go to maximum, which is the fourth one down. Now you're going to move Blinking Bob to the maximum because that's what you want. And then your calculator's saying left bound. So go to the left. So from that, hit left, 1, 2, 3. Hit enter. Now go back to what you want, that vertex, right? And then you hit the right button, because it says right, 1, 2, 3. Hit enter. When it says guess, hit enter again. And then you get this, 1.999. What is that? It's 2. And what is 3.9999?
3.99.
It's 4, right? Oh gosh, excuse me, language. 4, right? So 2, 4. So you can get it the same way. Just remember that this is also the maximum, yes? Okay. So y-intercept. What's the y-intercept?
2, 0. It's
0, 0.
Miss Osborne.
Yes.
It's 2 down, 2, 1 to side, 2 down.
All right. Oh, it's fine. I'll just sketch it. Okay. So, increasing and decreasing intervals. Let me see. I'm not going to draw my lines and, all my intervals in. I just want to see what you have. Who feels like their increasing interval is great? Can do this. Yes, Mary. What is it?
I put negative infinity to 4.
Negative infinity to 4. Is that right?
No.
Oh, my goodness. Why?
Because you use the X, not the Y.
You use your X number, not the Y. If you tell me 4, it means that your graph changed direction here.
Okay.
Okay, so then instead of 4, what should it be?
2.
2. Good job. All right. And you know what? Making mistakes is fine. I'd rather you guys made your mistakes here. Okay? So we can work through them together. So yes, here we are. 2 is here. Even though this is still going down, listen, we're talking about the X values. This is an arrow going to the left. So that's going to negative infinity. You have an arrow going to the right. So that's positive infinity. Right? Yeah. So now it's decreasing from 2 to infinity. Are you guys okay with that? Okay, good. So what about the end behaviors? Negative infinity. Oh, so what does that mean? If they're both negative infinity, does that mean that they're both going down? Yes. As x approaches infinity, that's talking about your right end behavior, is going down to negative infinity. As x approaches negative infinity, that's talking about the left, and that's also going down. Okay? All right, good. How do you guys feel about this? Show me with the thumbs. Are we here? Are we here? Okay, good. Perfect. All right. Well then, you guys have mastered the graphing. Great job. Now, you've already mastered it. Now, we're going to talk about equations and inequalities. Okay? So, here's just the basic overview. Okay, we're going to go through this quickly. You guys have actually done a lot of these. Equations. Make sure you have the absolute values all by itself. Okay? After you do that, then you make them into 2 equations. Remember, don't change anything that's inside the absolute value bars. They stay the same. Okay? If it's equal to 6, absolute value equal to 6, it becomes whatever was in the absolute value equal to -6 and +6, right? Okay, and then we want to make sure that the absolute value is equal to a positive number, okay? Otherwise, it's a no solution. You can't say an absolute value is equal to -1 because absolute value is always positive, right? All right, so now inequalities. Okay, so now we have less than or equal to, greater than or equal to, right? Same thing, get the absolute value all by itself. Now, what happens is when you break it down into two, you have to remember that you change what is it, change the sign? How should we say it? Flip the sign, and we make the number the opposite too. Okay? So the first one stays exactly the same. The second one, you flip the sign, you make the number the opposite. Yes? Uh-huh. So remember, the absolute value can never be less than a negative number, right? Because absolute value is always positive. So these are the no solutions or the all real numbers exceptions here, okay? If you have an absolute value is greater than a negative, right? A positive number is always greater than a negative, so that one would just be all real solutions. Yes? All right. So graphing on the number line, of course, open circles, closed circles. You know that, yeah?
Yes, he is.
Yeah. Yeah. See?
Did you think about?
All right, let's solve this. First of all, guys, okay, let's get it down to the absolute value all by itself, and then let's answer this. How many solutions are there? Okay? What should I do first? Thank you, minus the 11. Then we have 3 times the absolute value of x plus 4 equals -6. Now what? Divide by 3. Absolute value of x plus 4 equals what? Not -3, -2. Now, tell me, how many solutions are there to this equation?
0.
0? No solutions? Why?
Because this equals to negative.
Good. No solutions because, you know, when you get the absolute value bars all by itself, that's when you got to say, okay, let me evaluate the situation. An absolute value is a positive number. Can that equal a negative number?
No.
No. So this is a no solution. Okay? All right. I know, right? Next time, do that from the beginning of class. If you do it from the middle of class, it doesn't work. All right. So this one, let's do this. Guys, I want you to start it off for me. What should I do? All right, add the 20. So I have the absolute value of x plus 4 equals what? Okay, so now what? Positive equals a perfect. This works. I can keep going. And then what?
We can do 2 equations.
2. So the first one is what?
X plus 4 equals 3.
X plus 4 equals 3. Look at how you don't change the thing that's inside. And then what's the other one?
X plus 4 equals negative.
Okay. And then when we solve this, good. Now, if they ask you to graph your solutions, all you have to do is just put it on a line graph, right? Are these open or closed circles? Closed, because they're equals, right? Which one's further left, -7 or -1?
-7.
Yeah, so I'll just put -7 here. I'll put -1 there, and I'll put 0 there just for fun.
Yes, ma'am.
Stop it. And then here's an equals, and here's an equals. All right.
Yes, ma'am.
One more. One more. One more. I know, right? I think they want to go and miss out on all this SOL review
I
fun.
already finished.
I have a question.
All right, let's try this one. Yes.
For this one, I just don't.
All right, hold on. Let me go through this first. All right, so it seems like a lot of you guys are ahead. Tell me what I should do first here. Good.
Divide by 2.
All right. Divide by 2. Now, the absolute value of x minus 3 is less than or equal to 6. Can I keep going?
Mm-hmm.
Yes. So, be careful here. When you split these up into 2, what does the first equation or inequality look like? Same thing. X minus 3 is less than or equal to 6. How about the second one? All right. Greater than or equal to what?
Negative 6.
Good. Okay, so let's solve it. Now, with the inequalities, guys, is this an or, right? Like you have arrows going out? Or is this an and graph? It's an and? How do you know? What'd you do? It was less than? Oh, here, it was less than? So you remember that it was and? Okay, if you don't remember that, just kind of sketch a graph, okay? X is less than or equal to 9. X is greater than or equal to negative 3.
Exactly what I do.
Good.
No.
All right. So it's and. You could say X is and, right? Or you could write it like that. Okay? If it's an or, don't write it this way. Okay? What's wrong? Okay. All right, questions about this? Okay, next one. This graph best represents the solution to which inequality? Okay, I'm going to show you something. I'm going to show you something, all right? Go to your calculators. I mean, because we could do this the algebraic way, and that's fine, but I want you to know some tricks. So you're going to go into y equals, okay? Did anyone do this and actually get an answer? Yeah, what'd you get? What'd you get? You said yeah. You got B. Okay. So, B. No, we're going to go with B. You're going to go to math, number, apps. Let's put in B. X minus 11. Close. And then, what is this? Less than? So, go to second math. You see less than? Fifth one down? 4. Yeah? Now graph it. See if it looks like your graph. Whoa. Is that this graph?
No.
First of all, no. No. Well, negative 10 all the way to 4. See, you have to remember yours only goes to, oh yeah, negative 10, but it stops at 4. 1, 2, 3, 4. No, because this goes past 4. B's out. Who said, what was the other choice?
D.
D? Okay, let's try it. Let's put in D. Math, number, apps, 2x plus 7, less than 15. Graph that from negative 10 to what? 4? I don't know why it's doing that.
No, it's supposed to be negative 11.
Oh, negative 11. Ooh, then I need to go and see.
Yeah, it's supposed to
X
be.
minimum, I'm going to go to negative 15.
Yeah, it's supposed to be negative 11 to 4.
Oh, okay. So you know what my calculator's doing? these right on the axis, those are not part of the graph. This one that's floating, that's your graph. Yeah. Inequality?
Yeah.
Second math.
Oh.
Okay, second math. So yeah, if you had D as your answer, that seems to be the winner. It's a yes from Dylan. Got it. All right.
Done.
All right. Absolute graph or absolute value graphs. Here's the practice.
Where is it?
What is this? Didn't you already do this?
Yeah.
Who just did this one?
Yeah, we finished everything. No,
Wow.
we have.
All right. So here's what your JLab handout looks like. Okay. This is your SOL practice quiz assignment. These will be quiz points. So basically, you go to this website that's listed, JLabs, okay? You have to complete 3 20-question quizzes, all right? 3 of them. Each quiz is on a separate topic, and you'll receive 30 points if all your questions are completed correctly, okay? And here's the best part. You can take these quizzes as many times as you like. So ideally, you should get 100% on this, okay? Once you finish the quiz and you're satisfied with your grade, please email the results to me and to yourself, okay? Here's my email address. It's listed there for you. If you type in my email address wrong and it doesn't come to me, that is not my fault, okay? And after you send your JLab, if you want to send me an email just to confirm and say, Ms. Osborne, I just sent my JLab results. Can you just tell me you got it? I'll be happy to email you back, okay, and let you know. But that's why we recommend that you also send it to yourself in case it doesn't come to me, okay? So the assignment is due by Friday, May 26th. Strict deadline. However, you can still turn it in late. There's just a 5-point deduction for each day that is late. Okay? Your Algebra 2 SOL is on Tuesday, May 31st. Okay? And that is set. Alright? Your 3 topics that you're taking these quizzes on: equations and inequalities, expressions and operations, and functions and statistics. Those 3 topics. Okay? And please don't mix them up because your results show which topic you just quizzed on, okay? So basically, you can keep track of what your grade is going to be. You have, something out of 20, something out of 20 for each of these. You add them up, right? Take your total, divide it by 2. That's what you're getting out of 30, all right? So here's how you get started. The website is listed there, but if you go to Google and you click JLab, it's the one that has, with the education. Don't click the others, like some other weird lab thing. Yeah, but it is the Jefferson Lab, the education.jlab.org, okay? All right, so when you get to that page, you're going to click on Algebra 2. You're going to click on 20 questions, and you're going to put your name there, okay? Can I please emphasize that you need to put your name, not Mrs. Osborne? I've gotten that before. It's just not fun. I just don't know whose it is. I had a student write Mrs. Osborne because they were just copying this. I was like, excuse me, that's not your name.
Wait, can we put Miss R?
No, not Mrs. R either. So make sure you please put your name. I know it sounds silly, but I have to say it out loud, okay? And then click select additional options. Click on that yellow button, all right? Your directions here have arrows and everything. I mean, this is supposed to be, self-explanatory, but all right. When you click on select additional options, you want to make sure that these 2 are checked, and they will be, okay? But we just want to make sure that they are. Those are checked, that is checked, and click next options. Okay? Are we okay so far? All right, and then you're gonna go to, when you click on the next option screen, you're gonna see this. Click all years. And then on the next one, click on the topic that you're gonna be working on. Which quiz are you doing? Are you doing the equations? Then click on that one. Okay, when you get a grade that you are satisfied with on that one, then when you go back, you're gonna click on the next one and so forth, right? Click on next options. And then you want to click on random order, and then let's start. Okay, when you're done, it'll give you a recovery code. All right, and it actually has a deadline. Okay, but this is where you would put in my email. All right, that's it for the JLabs. Okay, please do not send me a JLab that is 50% and below, because I mean it's an F. I mean really 60% and below, that's an F, right? Don't send me your Fs, right? Try to get at least, I mean you should try to get at least an 80. Yeah, because all of you guys are capable of doing it.
You get extra points if you get over 30 points.
If you get over 30, no, there isn't really any room for like extra with this one. It only has those 3 topics, and just do the 20 problems, okay? All right. Okay? Any questions about the JLabs? All right, so make sure you put this somewhere safe. When does this due?
30, no. 26.
Oh my goodness.
It's the
When does this
26th of May.
due on the 26th?
It's a Friday.
I also wanted to tell you guys that we will be holding an after-school session to review for the SOLs, but we'll give you more details, when it gets closer to that time. All right? So just be mindful of that.